Trigonometric functions, expanded definition. In the original definition of trigonometric functions, we needed a right triangle, but now we want to define these functions for any size angle. In a right triangle, the largest non-right angle had to be less than 90 degrees. To illustrate this new expanded definition, we will look at an example where the angle is 150 degrees. Example: find the 6 trigonometric functions for 150 degrees. First, draw a sketch of this angle in the rectangular coordinate system. Draw a 150 degree angle from the positive x-axis counterclockwise as shown in the drawing. Then we find the reference angle that is formed by the end of the 150 degree angle and the closest x-axis. In this case, that forms a 30 degree angle as indicated in the drawing. The values for the 150 degree angle will be the same as the 30 degree angle except for the sign. Note, the only one that is different is the negative on the square root. The 2 along the hypotenuse will always be positive because it's the radius vector. The other ones will have the sign according to the sign of the x and y axis. So it's a negative the square root of 3 because in the negative x direction, and 1 is positive because it's in the positive y direction. Sine of 150 will be the same as the sine of 30, which is 1 over 2. So the sine of 150 is 1 over 2. The cosine of 150 will be the same as the cosine of 30, but it will be negative because of the negative square root of 3. So we get a negative the square root of 3 over 2. The tangent of 150 will be negative because of the negative on the square root of 3, and it will be 1 over the square root of 3. And we can rationalize it, although it won't be wrong if you don't. We'll multiply numerator and denominator by the square root of 3, and we'll get the square root of 3 over 3. Most students memorize which quadrants the different functions are positive in. This shortens the above process to finding reference angles, knowing the value of the trig function for that angle, and knowing the sign of the function in the quadrant the angle is in. All functions are positive in the first quadrant. Sine and cosecant are positive in the second quadrant. Tangent and cotangent are positive in the third quadrant. And the cosine and secant are positive in the fourth quadrant. So if you just memorize those, then it comes down to finding those 3 things. Once again, let's review that. You find the reference angle first. You know the value of that reference angle, the trig function value of that reference angle. And then if you know the sign in that particular quadrant, you'll have the answer. Example 2. Find the sine and tangent of 4 pi over 3. Solution. First, find the reference angle and the quadrant this angle is in. This is a third quadrant angle, and the reference angle is found as shown below. So if we go 4 pi over 3, will be in the third quadrant. And so we change 4 pi over 3 and subtract pi from it, and that would give us pi over 3. So once we have pi over 3, we could translate that into 60 degrees because the degrees are just easier for us to deal with, and our table was written in degrees. Sine of 4 pi over 3 then would be the same as the sine of 60 degrees, or pi over 3, and that would be the square root of 3 over 2. And in the third quadrant, the sign is negative, so we'll put a negative in front of it. Now, we didn't really draw the little triangle in, because now we're going by just what we already know. We've memorized the sign, which ones are positive in which quadrants. We've memorized the basic reference angle, the trig ratios for those angles, and so we just plug them in. So let's try the tangent. The tangent of 4 pi over 3 will have the same value, absolute value, as the tangent of pi over 3, or 60 degrees. And we know that the tangent of 60 degrees is the square root of 3. And we also know that the tangent is positive in the third quadrant. So we're able to do all of that because we know those basic ideas and facts.